Hello, this is Nikhil Raktale and I'm doing a video commentary on my soccer simulation project. This project was developed using Visual C++ and Gearlist. That was the 3D engine. I won't be going into a lot of detail about the source code in this video because that's just a bottomless pit. But I will be giving you the general overview of how the project works and some of the components. Uh, First off, I'll just execute the project and it show it to you in action. So it's more of a simulator than a game. So there's some amount of text input required. This is initially just asking for the direction of the wind. So supposedly I want a northeast wind. So I said using that. There's some field descriptor values which I've programmed some defaults in here. Just to show you which values are available, I'll press no. So the length, the field, the breadth of the field, the circumference of the ball, the density of the air. I tend to keep it a bit low. Higher values affect movement a lot. The mass, sorry, the mass of the ball and the pressure of air. So all these factors actually tie into the physics calculations. If you want some details on how the physics actually works, there's a project overview PDF inside the checkout, so you can open that up. There's a whole physics section. There's some scanned documents of my original derivations which you can go through. Also, this project was a simulation, so the problem statement for this is also available inside the checkout. You can just open it up and see the problem statement. This was made for a competition. I won the first prize for the competition, and they gave us a problem statement, a problem to solve. So that problem statement is available right here. So yeah, after giving all this input, you just press return. Uh, it shows you the maximum applicable force on this ground. The maximum applicable force is also defined inside the problem statement. And yeah, just press return, and yeah, this is the game screen. Controls are pretty easy. A moves the ball left, D moves the ball right. Press F and a force direction indicator shows up, and now you can use W, S, A, and D to move it around, to point it to wherever you want to kick. As long as this is active, you can't move the ball. Press F again, and you'll be able to move the ball again. So press F, and I'll aim it here. So once you've aimed it, you can use the mouse wheel to increase, decrease the magnitude of the kick. So let's say that's the magnitude one set. The sphere goes, becomes bigger and smaller according to magnitude. And you just left click to kick, and yeah. So as you can see, the ball went into the goal. Nice, and yeah, it just keeps on looping in the trajectory. The game also goes into this FPS cam mode, so you can fly around, see the trajectory from various angles, like here. There's a bit of a bug in this version. The version of Yearlist that I'm using now is, you know, not the same as the one that I used to develop it. So this version doesn't really support the old editing tools and the scenes created by that. So there's some problems in the skybox. I hope that you'll forgive this minor issue. So yeah, just press space, and that's the next player's turn. Each player gets 5 turns. If there's no decision at the end of 5 turns, then you go into like sudden death mode, and keep pressing space to reset the game after anybody's won, and just press escape to quit the game at any time. And normal execution does not give any kind of memory leaks or anything. So yeah, that was the project itself. I'll just talk briefly about the code. Um, as I said, this was developed using C++ and Yearlist. The whole project basically revolves around calculating all the points on the trajectory, and then the graphics basically works to show you the path as it would be traversed by the ball. So the physics part of it basically just deals with deriving all those points. So what I did was my physics calculations, they just run using small intervals of time and over again. So every say half a second, I calculate the next point where the ball would be, and push them all into an array, and then Yearlish provides an animator feature which allows you to follow a spline or follow a set of points. So just follows those points and displays all of that on the screen. So yeah, the game starts off from the soccer sim.cpp. I tend to have a central repository of all shared data in the game. So this game data class has um, all the shared data, like things like the football object, the direction indicator object, the magnitude indicator object. Everything's accessed from here. These are unique objects inside the game. They just created once, so created here, held here all the time, and these pointers are used by different sections of the code to manipulate these objects. Uh, Oh, however, these objects are not directly manipulated. They're manipulated through, whatever methods that would be exposed. So if the ball is to be moved left, the ball is to be moved right, and all these things have been defined in here, like um, mm, yeah, the move ball left method and the move ball right method, and all the checks which are associated with not letting the ball fall out of the screen and all that. It's all programmed in here. So the other sections of the program just call relevant methods and hope for the best. So yeah, I'll get to the physics portion. There's a lot of graphics related code in here which I doubt it's any use explaining all of that. I guess you can just open up the project and have a look over. So yeah, uh, this kickball method and the calculate points method is where the meat of the physics calculations is. Uh, the calculate point method calls itself recursively. It takes an origin and an initial velocity. So I realize that every bounce occurrence is basically the same. You have an origin point and a ball moving away from the origin at some particular velocity. The rest is basically the same. So what happens is, as at every bounce, this method is called again, and it calculates the points from that origin to the next bounce point or till it crosses the field boundaries. So yeah, this is all the physics that has been implemented in code. You can again go and see what these calculations actually are doing inside the project overview PDF. Um, and this is where it's calling the method recursively. The kickball method is what is called from outside. It's called from the event receiver, which is also an important part of the project. Yeah, so this is the kickball method, and yeah, the event receiver handles all of the user's input. uh, so the on-event method is a callback method which is called by the engine whenever I guess there's an interrupt or something. It's again another feature provided by the Yearlish engine, and this thing handles depending on which key is pressed, to move the ball left or right. So as I said, and depending on some conditions, move the ball left. So yeah, this thing handles all the user input. respective portions of the code have encapsulated all of the operations that can be carried on them, like the ball has kicking and movement of the ball, the force magnitude indicator has its movement and all written into it, and the soccersim.cpp just starts it up and starts up a game loop. This is just here to conserve some CPU time, otherwise this loop just keeps on running, hogs up all the CPU cycles. So this thing sets up a game loop, and the engine works by drawing scene elements which have been added into it, so it's just drawing all of those. um, yeah, so that's about all the information. As I said, I won't really go into a lot of detail about the graphics code. My code tends to have a lot of comments in it. I tend to put in headers and whatnot. So I hope that at least my comments will help you in deciphering what exactly is going on here. So yeah, thank you very much for taking the time to watch this video.